With this video, we're going to look at just that next step of solving quadratics. We're actually going to look at solutions. And so we're going to still look at factoring, but we want to look at what happens when the equation is set equal to 0. That means we're looking for solutions or zeros to the quadratic. And they will make more sense when we look at the application pieces. So we've got some examples here, and going back to the factoring piece, but I want you to look at everything. It's different than what we've talked about in class because now we have equations involved. So this first one, I have x squared minus x minus 20 equals 0. We've actually worked one of these in this one in class before. A is 1. C is negative 20, so 1 times A would be negative 20, and it needs to add to give me negative 1. This factors would be 5 and 4, and it's got to add to give me negative 1, so this one would be negative, this one would be positive. A is 1, so you're allowed to write x minus 5 times x plus 4. Now, that's kind of where we stopped recently, but since this is an equation, what we're looking for are what are the values of x that make this equation equal 0. So an organization piece to this and to continue the process is to figure out what x can be. So I would take the x minus 5 factor, set it equal to 0, and the x plus 4 factor and set it equal to 0. So that's what you're doing. You're just trying to figure out what those are, solving that simple one step. Just add 5. So what you get as a result are intercepts and x-intercepts. So when I subtract the 4, I get negative 4. So negative 4 and 0 and 5, 0. So these are points on the graph, and these are also called your solutions. I will go to the graphing calculator on a couple of these, not all of them, because we'll do a lot of those in class as well. But I wanted you to see what the result is now. It's not, we have stopped there in the past, but now we're simplifying it, or excuse me, not simplifying it, but solving it now for what those x values would be. So when you substitute a 5 in here, 5 minus 5 gives you 0. Or you could substitute a negative 4, and negative 4 plus 4 gives you 0. So you have two solutions to the quadratic. Part B, you've got x squared plus 9x is equal to negative 14. And we want to set this equal to 0, so we're going to use the inverse operation and add 14 to both sides. So when we do that, that gives us x squared plus 9x plus 14 is equal to 0. And A is 1. You're looking for 1 times 14 is 14, and it has to add to 9. So those factors would be 7 and 2. So A is 1, so I'm allowed to say x plus 7 from here, and x plus 2 from here, and I'm going to set them equal to 0. So now take each of the factors, and so x can be negative 7 and x can be negative 2, and remember those are ordered pairs, points on the graph. So if I go to my graphing calculator and share that screen with you, and so if I go to, and I want to type in x squared plus 9x plus 14, I would say x squared plus 9x plus 14, and I've got my equation, and that's what we'll do with our TI-84s in class, is we'll type that in, and we'll look at let me type that in again, and that will be x squared plus 9x plus 14. And notice that you've got 2 points where the quadratic crosses the x-axis. Those are called your intercepts. And if I look at my table, which we will look at our table as well, when I look at my table, I'm looking for values when x is -7. Notice that when x is -7, what's the y value? It's 0. So that would be this point right here. Are there any other values? And you keep scrolling and you see when x is -2, you also have 0. So those are called your zeros or your solutions to the quadratic. So coming back to the next one, I've got 3x squared plus 6x. And see, this is equal to 45. Well, I want to move the 45 over, so I'm going to subtract 45 so I can set it equal to 0. Now, we're factoring, so we want to see, can I factor out that 3? And I can. 3 will divide each of these terms. So I'm left with x squared plus 2x minus 15. Set it equal to 0. A is 1 right here. So I know that this will factor. So when I take 1 times -15, I've got -15, and I'm going to, it has to add to 2. And so that would be 5 and 3. And that will be a +5 and a -3. And since A is 1, I have these factors I can use, x plus 5 and x minus 3. So the 3 is needed. It's part of the solution, but x plus 5 is equal to 0 and x minus 3 is equal to 0. So what you're going to have is x equal -5 and x equal 3. So -5, 0, and 3, 0. Those would be the solutions or zeros or x-intercepts to this quadratic. Part D, I've got 5x squared minus 44x plus 120 equals -30 plus 11x. So I'm just going to move all the terms to the left side. So I'm going to subtract 11x and subtract it here. And I'm going to add 30 and I'm going to add 30. So that goes to 0, that goes to 0. You're left with 0. You're going to get 150 here for the constants, -55x for the middle term, and 5x squared. So 5, 55, and 150. 5 will be a factor. You always want to check, can I factor everything by that leading coefficient? And you can. So it'll be x squared minus 11x plus 30. So you're checking to see, okay, I've got 30. The factors have to multiply to give me 30 since A is 1. And they have to add to give me a -11, so it'll be -6 and -5. And so I get 5 times, and I get x minus 6 and x minus 5. So x minus 6 is equal to 0, x minus 5 is equal to 0. So my intercepts would be 6, 0 and 5, 0. Part E, I've got 3x squared plus 2x minus 8. And I have A is not 1, but you see A will not divide any of these. So we're back to our factor by grouping, and I'm going to take 3 times -8, and I get -24. I'm looking for factors of -24 that are going to add to give me 2. And that should be 12. No, sorry. 6 and 4. And that will be negative, and this one will be positive. So A is not 1, so I need to rewrite the first term and then fill in this middle term with these two. So I'm going to write the negative 4x first, then the positive 6x, then minus 8. Okay, so I've got my 4 terms. This is what we did for quiz 1. I'm going to group and then find the GCF. Well, the GCF of 3x squared and 4x would just be x. So you get 3x minus 4, and 6x and 8 would be 2. So you're left with 3x minus 4. So what are your two factors? It's x plus 2 and 3x minus 4. And then set these equal to 0. And you're going to get x equal negative 2, which would be negative 2, 0 as an intercept or a solution. And here you're going to get x is equal to 4/3. So 4/3 comma 0. Now let's type that into the calculator just so we can see that. And so we're going to go to graph and we're going to type in 3x squared plus 2x minus 8. And we see our graph, and notice we have two solutions. One looks like it's right on the crosshair, and one that's not quite. Well, that one on the crosshair would definitely be our negative 2, 0, and this 4/3 0 is 1 1/3, and it looks like it's going to be right there. So if we look at our table, we see that if I scroll up at negative 2, I get 0. But I'm not going to see it at 1 1/3 because these increments go up by 1s. So if I go to menu, and if I go to remove my table, and if I go to trace, I should be able to see when that 4/3 would be at that point right there. And so we'll talk more about using the trace button and typing in the value. So when we type in 4/3, we would get 0 as a result. So go back to our whiteboard, and we'll look at this last one here. And I've got 7x squared plus 2x equals 0. And notice I don't have a constant term. Constant is 0. So the only thing I can do is I can just factor out something in common, and the only thing they have in common is x, and I get 7x plus 2 is equal to 0. So, and that's okay. We didn't have to go through our factor by grouping. The only thing they have in common was x. So we take our factors. So x equals 0 and 7x plus 2 equals 0. So x would be to subtract 2 and divide by 7. So the two solutions would be 0, 0 and negative 2/7. Next, we're going to look at some examples of some application. So we're looking at an area model that's rectangular. So basically we're looking at something that's a rectangle, and I know that the width here, and the width here, and the length I know is 9 meters more than the width. 9 meters more than the width. And the area is 252. So what you have is W, length times width, and you know it equals the area. So you're going to get W squared plus 9W equals 252 after you distribute. And so I want to subtract the 252, and that's going to give me equal to 0. So what I have is A is 1, and so I'm looking for factors that multiply to give me negative 252 and add to give me 9. And this is something we'll look at on the calculator in class as well, and that is how to find, let the calculator help us find different factors. So what I'm going to do is take that 252 that we're looking for, and so I'm going to go to graph a function, and I'm going to write 252, and we'll type in 252 divided by x. And what I want to do is look at the table. So what I have is 252 divided by x. All of these are factors of 252. What I'm looking for is the one that adds to give me 9. The difference would be 9. And right here I see 12 and 21, and that difference would be 9. So I would have 12 and 21, and has to add to give me positive 9. So this would be positive, this would be negative. Since A is 1, you would have W minus 12, and W plus 21 is equal to 0. One of these factors, one of these solutions will work, one will not. When I solve W plus 21 and set it equal to 0, and I get negative 21, that's not going to work because it's negative. So what we have is a width of 12, and yes, 12 plus 9 is 21. So the length and width would be a 12 by 21. That would be the dimensions of the garden. Now, if you take the floor of the central chamber of the Lincoln Memorial, and we'll say that that area is 4,440 square feet, and I've got a width and I've got a length, but I know that the length, it's 14 more than the width. So this will be very similar to the previous problem. And you can distribute, and you'll get W squared plus 14W. I want to subtract this over so I can set it equal to 0. And again, I'm looking for factors, since A is 1, that multiply to give me negative 4,440 and add to give me 14. And so we'll use the calculator tool in class to acquire those factors, especially with larger numbers. And what we would have is 74 and 60. We would find those. So since A is 1, we would just write W, by the way, that would be negative 60. So we'd have W plus 74 and W minus 60, all equal to 0. One of these is going to work, and it's going to be this one, because when you solve for W, you get a positive measurement. You solve for W here, and you get a negative measurement. So the dimensions are going to be 60 and 14. So 60 by 74 would be your results of your length and width. This one, Avery's planting a vegetable garden in the shape of a right triangle. and the longer leg is 3 feet longer than the shorter. Okay, so we'll say this is the longer, and it's 3 feet longer than the shorter. We'll call this the short side, the longer side, and the longest side. And the hypotenuse, which is the side opposite the 90 degree, is 3 feet longer than this leg. So what we have is x plus 6. So since we're using a right triangle, we're allowed to use the Pythagorean theorem. So a squared will be the short side, the longer side, and the longest side. So we'll say x squared plus x plus 3 squared is equal to x plus 6 squared. So this will be x squared, and then multiplying this out, remember this is an x plus 3 quantity square, so it's x plus 3 times x plus 3. And so a shorter way to multiply that out is you can square the first term, multiply 3 and x and double it, and you get 6x, and square 3 and you get 9. That works for any way you want to multiply a binomial square. You can take that same approach just like we're going to do here. This is a binomial square, so I'm going to square the first term. I'm going to multiply 6 and x, and I get 6x, but I'm going to double it to get 12x, and then I'm going to square 6 to get 36. So over here, like terms, I'm going to have 2x squared plus 6x plus 9, and x squared plus 12x plus 36. And I'm just going to move every term over to the left. So I'm going to subtract x squared. I'm going to subtract 12x, and I'm going to subtract 36 from both sides. And what I would get is x here, x squared here, negative 12x here, and negative 27 here. And of course, I subtracted all of those, so that all goes to 0. Since a is 1, that's nice. So you're thinking of factors that multiply to give you negative 27 and add to give you negative 12. And that's negative 6 right there. Typo there. So that'd be negative 6x. 6x minus 12x. I didn't subtract it. I ended up writing the 12. So 6x minus 12x will be negative 6x. So you're looking for factors that multiply to give you negative 27 and add to give you negative 6. And that'd be 9 and 3. 9's negative, 3's positive, a is 1. So we're going to come over here and write x minus 9 and x plus 3. And all that's equal to 0. So one of these will represent a positive length. When I set this one equal to 0 and solve, I get x equal 9. When I set this one equal to 0 and solve, I get negative 3. So that's not going to work. So what does this mean? This means 9 is the short side. So it will be a 9. 9 plus 3 is 12. And 9 plus 6 is 15. This is a 9, 12, 15 right triangle. Here we've got a swimming pool, and we know that the dimensions are 30 by 40. But the club members want to expose a border around it. And we just don't know how much the strip is. But we know that this is x, this is x, this is x, x. We just don't know these measurements. So take, for instance, the length here. Well, we know it's 30, and this is unknown, and this is unknown. So all the way across, we have x plus 30. So that would be 2x plus 30 as our length. And this way would be x plus 40 plus x. So you get 2x plus 40. Now I want to know how long the strip, or how wide the strip is. So if I were to subtract out this area, then I would be able to know and begin solving for that x. So what I'm going to do is subtract 1,200, because that's what the area of the pool would be. And the materials that I have are 296 square feet. So what I have here is the new area, and this is the pool area, and these are the materials for the strip. But what I need to do is simplify, so I need to multiply all these out. So that'll be 4x squared, and then 2x times 40, that's going to give me 80x. 30 times 2x will give me 60x, and 30 times 40 will give me 1,200. And then I'm going to subtract the 1,200, and that's going to give me 296. So these will go to 0, so I'm left with 4x squared plus 140x. I'm going to subtract the 296 out, and I get 0. So since we have a is 4 and not 1, we want to try to divide everything by 4. And everything will divide by 4. And so that would give us x squared plus 35x minus 74. So since everything was able to be divisible by 4, now we're back to a is 1, and you're looking for what are factors that multiply to give me negative 74 and add to give me 35. And it would be 37 and negative 2. And so since a is 1, it would be x plus 37 and x minus 2. So the final, don't forget the 4 as part of the final product. And then when you set just the factors equal to 0, well, this is the only one that's going to work to give us a solid or a positive answer. So that just means that the border width was 2.